In tomorrow's session we're gonna implement the save to db functionality, clearboard functionality, and one more functionality that we're gonna discuss it uh, about in upcoming class. Okay, so if you see, if I do like this, okay, I have written c. If I do recognize, you can see I'm getting a result c c c c c. Okay, so basically for every time I move the cursor with some new data, the ink is getting built and the model is able to recognize it. Okay, so if I do something like this, so according to you, Raj, this word seems to be like letter D, right?
Yes, sir.
Okay, let's see what will be the output. Cool. It is still showing it's of type C. Okay. Uh, though we have to do little work on this, but what I wanted to represent here is if I do this, okay, and if I do this, okay, correct, yeah. So basically, what I wanted to showcase here is though we are trying to write alphabet D, the the AI is able to recognize it as a two letter, two word, basically two alphabet. That is C and L. Okay, but not D. Okay, so see now when I have written it in a one flow, okay, then the recognizer is able to recognize that this letter is this alphabet is D. Okay, so if I run it out again, if I do this, see, uh, based on how I give the input or how I create my object and provide it to the recognizer is able to give me output based on that. Okay, the problem is that it is still not very efficient and ready to use thing. Okay, but eventually we're gonna be going to build it optimized app so that anyone can use it for the day-to-day basis. Okay, so to implement this we need to go to here, which is the digital link recognition uh, documentation. I'm sharing the link over here. Okay, so now it says that with ML kit digital link, you can recognize handwritten text and classify gesture on a digital surface in hundreds of languages. Okay, as well as classy sketches. Okay, अगर मैं ई लिखता हूँ या आ लिखता हूँ या in different language I write something based on the model I gave, the ink recognition is able to recognize the stuff. Okay, now this thing is completely different from the text recognition, right? Raj, when you were learning about text recognition, we were hovering our camera over to a text paragraph and try to recognize it in different languages, right? But here we are giving an input in the form of a ink. Okay, ink means whatever I am writing over the surface. Okay, now, this converts the handwritten to sequence of characters, Unicode characters, that we're gonna learn more about it in upcoming session. Okay, but you can see uh, you can see that if I have written something like this, so how the text, how the ink recognizer understand is about with the help of the strokes that we have created. Okay, so for example, like if I have created strokes like this, H like this, so this stroke will consider to be one one stroke with the offset values of different offset value list of offset values. Okay, 392, 391, 389. Okay, something like this, and we're gonna implement the same in our app. Okay, so t is the timestamp or the delay from where it was started, like from where this x and y point was started, and from in the next iteration where was the next stroke on which timestamp. Okay, so it helps the ML model to understand, okay, the person is trying to write this, okay, based on this pattern. Okay, now when you send this ink to a recognizer for this English language, it returns several possible transactions containing 5 or 6 characters, right? So we have recognition candidates, and based on that, we can uh, take the value that uh, we wanted with the best output rate. Okay, best possible output rate. Okay, but we're gonna have a look into that in a much more detail over upcoming session. Okay, now, to differentiate between handwritten alphabets, letters, and some few gestures, we need to do certain configuration for that. Though it is out of scope, but if you like, you can do that using those gesture commands. Okay, so this is something different from what we are doing here. Okay, similarly, not only just letters and things, you can also do sketches. Based on the sketches you provide, you get the respective emojis output from the AI model. Okay, this is our AIML model. Okay, so uh, it's I hope you understand what this digital ink recognition is doing. Okay, let's see more information of how we can apply the same in our Android project. Okay, uh, there is one more thing that I wanted to showcase. I think it was in the, yeah. So the digital ink recognition API uses the same technology that powers handwriting recognition in Google keyboard and Google Translate. Okay, so you can understand how much data is been trained upon, and how good this model is, and how well you can use it if you have implemented in the right order. Okay, so if you are Android user, whenever you open a your keyboard, there is a way that you can you can write your letters, and the keyboard will understand based on your handwritten work. Okay, though that's a very very complex software, but internally it uses the same thing. Okay, now coming to the documentation. Okay, uh, it says that with MLKit, you can recognize handwritten digital service with regarding with 100 of language available. Okay, you can see the 100 of different number of languages supported by the model over here. Okay, now they have provided a sample app as well, which is little old, based on the view system. If I go to here, okay, if I go to here, drawing view. Okay, so uh, it is based on some XML stuff. Okay, this is something XML stuff that we don't generally see in our latest app, and we haven't gone through the XML things yet. So we're gonna implement those all the things in our compose code. We're gonna see how we can achieve that. But for other things of understanding, we can go through the manager class and other other classes to understand how things work. Okay, but first let's go through the documentation provided by the ML kit official documentation. Okay, they said that first implement this, include this library into your app using this dependency. Okay, while implementing this dependency, though in our project we have already did so. Okay, let me run it again. Okay, so I have already added this part over my app level grader. Okay, now what it is saying, uh, the main way to build an ink object is to draw it on a touch screen. Okay, on Android you can use a canvas. Okay, for this purpose your touch event handler should be called the add new touch event callback, shown the following code snippet to store the points in the strokes the user draws into the ink object. Okay, now if you see this code, okay, there are more than few things that we need to understand. Okay, हमने सबसे पहले एक इंक बिल्डर का ऑब्जेक्ट बनाया विच डजंट कंटेन एनी डेटा। फिर हमने स्ट्रोक बिल्डर का एक लेट इनिट वार बनाया। ओके, लेट इनिट इज समथिंग दैट वी गोना initialize a variable after doing some, after few uh, uh, process of few other objects. Okay, now we have this add new touch event callback which give us of type param of type event which is of type motion event. Okay, and based on this motion event we are doing certain things. Okay, but first let me explain you this part. Okay, let us consider this is my Android screen only. Okay, let me not do it like this way, let me do it with a little zoom part. Okay, cool. Assume this is our touch screen and this pencil is our finger. Okay, now once you tap on this screen, this is one of the event. Okay, and when you drag thing, okay, this is one event, and when you lift your finger up, this is one event. Okay, so in the documentation, when they say action down, action move, and action up, this simply means that when you just hit the uh, when you just hit the screen with your finger in the canvas, okay, this is action down. Okay, then you are putting your finger over the keyboard. Okay, and when you take your finger and drag things from point A to point B, okay, then throughout this thing you are doing the move motion. Okay, okay, and once you are done with your drawing, once you lift up your finger at this point, at the B point, this is up motion. Okay, so now try to understand the complexity. Okay, that whenever this is for a straight line, this makes a uh, good understanding that yeah, this is something making much of a sense. Okay, but if you are writing something very complex, okay, something like how are you, okay, so you can see in this iteration I'm not only have done lots of down move and uh, up gestures, but like here the series of those gestures were too much. Okay, like when I was writing the H letter, I did this operation one time. Okay, then for this two I for those two alphabet I, let's say I did it for the one more time, then I lifted my finger, started with the implementation of this. Okay, then for this, okay, then for this, even for this I need to do it for the two time. Okay, so you can see almost six times I am going through this event, and I have to very technically handle those events in order to give proper inputs to my machine learning model. Okay, cool. Let me stop here and let me first ask Raj, are you able to understand the motion event types, how those are triggered?
Yes, sir.
Cool. Okay. So in the documentation, when they say action down, action move, and action up, we generally mean by those events that I have just mentioned over this diagram. Okay. Now ये तो हो गई एक बात कि हमें इस चीज में करना है, राइट? नाउ द थिंग इज हाउ वी गोना नो that this action event is been need to be triggered. Okay, so for this, let me close this part. Okay, uh, let me create a new file here. Okay, let me create uh, a, a column, let's say. Okay, here I'm gonna provide a modifier. Okay, coming from the parent, coming from the parameter. Okay, saying that field max size. Okay, now I'm doing here input pointer input type. Okay, uh, just a second. Motion, I almost forget the name of that method. Let me have a look. uh, Pointer interrupt filter. Okay, pointer interrupt filter. Okay, I was getting confused between pointer input and pointer interrupt filter. Okay, so we have to use this one. Okay, you can see here I'm getting event type. Okay, of motion event, right? And I can do when event. Okay, let's give it true just to make the compiler happy for a time being. What's the acha? So using this interop, we need to use this compose experimental API over our method. Okay. Now my event is showing me warning. Uh, let's see, action up, action down, and action move. Okay. So we are able to get those things from this pointer interop filter. Okay. So generally in compose, if you wanted to add any property or provide some more inputs things from the user perspective, you gonna have to look out things that you can do with the modifier. Okay, modifier have all the things, all the basic things that you might require in your uh, uh, app features that you wanted to implement. Okay, so I wanted to implement things on the basis of motion events, happening through my fingers over the content of my screen. Okay, so what I did, I wrapped my column to the whole size of the uh, available space. Okay, and whatever I write here, okay, whatever I write here, the things is been executed and been shown in the UI. Okay, so the whole point was to showcase you that if you wanted to access those event callbacks, you have to use this pointer interrupt filter, which gonna gives you a motion event, and then you can use it to do certain things. Okay, so for time being, I'm gonna delete it and move forward. Okay, now we're gonna come to the canvas part soon, but let's try to understand this part as well. Okay, now every time a event will happen, okay, whether it is down tap down, drag event, or tap up event. Okay, there are many event like drag horizontally, drag vertically, okay, drag diagonally. There are many event that the Android framework detect for us to enable different kind of animations and features in our app. But majorly we gonna just work around with the down move and up gestures. Okay, so what I was saying, I forget the context. So whenever I do this down move or up event, okay, uh this callback that I showed you, okay, add new touch event will be get executed. Okay, and based on that, uh you gonna filter it out, okay, based on the event been happening. Okay, and do certain things logic wise in order to create the required ink object to provide it to the recognizer. Okay, now just to break it down, let me create another screen here. Okay, whenever you do tap down event, okay, based on the based on the device you've been working upon, okay, this event, this callback will help you based on the event, help you to track down the coordinates for the x axis and coordinates for the y axis. Okay, then in the stroke builder we gonna add a point. Okay, while providing the x and y coordinates. Okay, and in the end, when the action up is been happened, we gonna um in the ink builder object we can gonna provide all the strokes that we have added so far. And once this ink builder will be ready, we gonna uh, send this ink builder object to our recognizer. Okay, so the main point here to understand is that in order, acha, let me showcase you this diagram again. Okay, in order to give these values of those coordinates points, we are doing this logic implementation. Okay, so whenever you do this, let's say in a whiteboard you try to write h. Okay, so internally what you are doing with the documentation code that we have seen, uh, the stroke is handling all those points at specific areas. Okay, so that whenever this data has been transformed to the machine learning model, okay, machine learning model, we are able to get some output based on the data how the machine learning has been trained for. Okay, so we are just collecting those strokes here. Okay, we are just collecting different strokes based on different inputs we are getting. Okay, and then once the last action has been happened. Okay, action up has been happened on whenever we hit the recognize button here. Okay, whenever I hit the recognize button, whatever the data has been calculated so far with the coordinate system, I'm gonna send it to my model. Okay, cool. अच्छा, लेट मी नो, अगर मैं इतना सब कुछ इम्प्लीमेंट करूंगा, ओके, will it gonna be uh, will it gonna be do this stuff as well, like writing over the UI as well? अगर मैं ये सब implement किया, sorry, with my trackpad facing issues. Okay, let's say if I have just provided this lambda, okay, and try to build this app, would you think that I will be able to see this output as well, like seeing those okay text, those tick text, or not? Or we have to do this separate implementation of it? अच्छा राज, मेरे क्वेश्चन समझ में आया मैं क्या कहना चाह रहा हूँ? माय क्वेश्चन इज कि अगर मैं जितना डॉक्यूमेंटेशन में दिया है, अगर मैं बस उतना करूँगा, तो क्या मेरे को यूआई में भी चीज़ें हैंड रिटन दिखना चालू हो जाएगी या नहीं?
नो सर, तुम लोग को उसको रीड भी करना होगा।
करेक्ट, करेक्ट, एब्सोल्युटली करेक्ट. This is one thing that people generally don't get it initially, कि आप इस चीज से चीजों को ट्रैक कर रहे हो. ओके, बट once the things has been tracked, you have to save that value in a somewhere, and using that value you have to build the UI explicitly. Okay, uh, to do so we need to take help of canvas object. Okay, now what is canvas? If you see this excel raw thing, this is nothing but a very huge canvas. Okay, where I can build stuff. Okay, if I write something, it is possible because of the canvas. Okay, so the canvas class hold the draw calls to draw something you need for basic components. Okay, you need four basic components: a bitmap to hold the pixel, a canvas to host the draw cell calls, a drawing primitive, okay, and a paint. Okay, so we're gonna have a look into this in a detail. Okay, first let's understand little about graphics in compose as well while moving forward. Okay, I'm sharing this link over the meet as well, so if somebody is interested can have a look. Okay, just a second, give me a second. Cool. So if we go to the documentation of graphics, okay, here they says that many app needs to be precisely control exactly what should be drawn on the screen. This might be as small as putting a box or a circle on the screen, or having any different other styles of implementation. Okay, so in our case, if I clear the board again, okay, in our case मेरे पास एक कोई भी ऐसा कंपोजेबल नहीं है कि मैं उसमें ऐसे हैंड ड्रॉन करूं. ओके, एंड अगर मैं इसमें ऐसे कुछ हैंड ड्रॉन करूं, ओके, देन इट गोना गिव मी दिस आउटपुट, राइट? दिस इज सम काइंड ऑफ अ control that I wanted out of the scope of the things that has been provided initially by the compose framework, right? वो कुछ ऐसा नहीं प्रोवाइड करते कि आप बस लिखते जाओ वो चीजें होते जाएगी. वी नीड टू डू certain implementation of it, right? So we're gonna see how we can do that. Okay, now as I mentioned, modifier gives you all the required things in order to achieve almost all the things that you see over the Android application. Okay, जैसे कि मेरे को ये चीज़ें अपना हैंड रिटन बनाना है, what I can do, I can take a modifier, I can call this draw behind lambda, and this lambda gives me a draw scope. Okay, अब इस ड्रॉ स्कोप में I can call whatever helper function is been provided by the Jetpack Compose framework. Something few name few if I name few that are like draw rectangle, draw circle, draw line, draw text, draw image. Okay, and with the use of that, now I have precise control over each part of my item in my draw scope. Okay, so if you do go to modify dot like if you wanted to add a draw behavior like arbitrarily over your any of the Jetpack Compose component, okay, you can do that using the modifier draw behind callback. Okay, but if you want it explicitly to mention of your custom items, you can use the canvas composable. This canvas composable by default gives us a draw scope. Okay, and inside it we can draw our things as per our need, and trust me, almost anything is possible using this canvas composable. Okay, it's up to the limitation of your imagination, okay, of what you wanted to do, but you can almost reach anything using this canvas composable in your app. Okay, just a second, I'm coming. Apologize for that. Okay, so continuing on the same, what I was able to convey here, that using the canvas you get a draw scope thing. Okay, now what do you mean by draw scope? Draw scope is a special scope. Inside that only you can call those draw rectangle, draw line methods. Okay, so to uh, to keep some foundations inside it, this things has been designed and been provided. Okay, now this canvas draw scopes gives you the size property by default. This size property gets adapted based on the screen size you have been inflating this canvas and the modifier value that you give. Okay, this is relative to the values and the device you have been using. Okay, so here you can see in this example, when I'm drawing a rectangle, in the size I am giving the half size of the full length of the device. Okay, so this is the full length. I did size divided by 2, I got the half length, and I'm using that to draw a rectangle over here. Okay, so it's gonna take the half size from here and half size from this uh, y-axis and from this x-axis, and you will get this output. Okay, now when working with the canvas, it is very important to understand the coordinate system. Okay, if I come to here, okay, generally how we learn coordinate system in our high schools and in our college, is something like this. Okay, something like this. Okay, here you're gonna have a plus plus. Okay, you're gonna having a plus minus. Okay, something like this. You go study and you see that the origin is at the middle of the plane. Okay, middle of the plane that you've been having a coordinate system. Okay, but this is something similar in Android as well. Okay, but the origin that you see the 00, it is not at the middle but at the top of your screen. Okay, so with this logic, having this zero origin at the top is to cover all the Android screens been available throughout the world. Okay, so having at the top gives us more control that the x axis highest value for the visible screen will be the width value of the uh, device. Similarly, the highest value will be height of the device to showcase anything over the UI. Okay, and using this coordinate system, the values you provide, based on that you can draw certain elements at specific offset so that to get the desirable output. Okay, so here what they are doing, they are drawing a line. Okay, which start from the canvas width, goes to the uh, goes to 0f. So canvas width will be, if this is our application. Okay, so if it is 0 0, okay, here the value is canvas width and the y value is 0. Here the value is canvas width is 0, canvas height is canvas height. Okay, okay, and here the value is canvas width. Okay, and canvas height. Okay, so they are saying that draw a line where the start point of the line will be the canvas width and y will be 0. So it will be starting from here. Okay, and then the offset will gonna end at 0 here and the canvas height. Okay, so the x will be 0 and y will be the canvas height. So x0 is here and canvas height is here. Okay, so if you execute this code, you're gonna get a line from here to here. Okay, so this is just to the representation of this uh, code. Cool, cool. If they have added any readme here, cool, but we're gonna see the output of it in a second. Okay, but my point is that you want to do anything customization that is not directly been provided by the layout of composables, we can still achieve our desirable output using this canvas API. Okay, see, you can create draw circles using those handy methods. Okay, you can create uh, squares, you can create rectangles, you can create ovals, you can create lines, you can create path. Okay, uh, you can move your object from one place to another using the translate. You can rotate your object. Okay, uh, you can provide some insets that I wanted to provide some padding from here and there. Okay, you can do multiple things using this with transform lambda block, where you not only wanted to rotate as well but translate the things from one place to another. Okay, so There are various things that you can do that is required in order to build almost anything possible that you can think of. Okay, so draw, you can even draw text, uh, you can draw images using the bitmaps. Okay, and you can draw basic shapes that I have already shared, including circles, round rectangles, a draw line. Okay, oval. If you wanted to just draw an arc, this is possible. You can define points. Okay, but in our case what we are needed is a draw path. Okay, draw path, because when I'm gonna do something handwritten, let's assume this is our canvas. If I do something handwritten here, okay, I wanted to have this offset value of this respective strokes. Okay, uh, to my model. So you can see this is not a rectangle, not a oval, not a, square, not an arc, but this is a collection of lines. Okay, uh, build up together to create a path. Okay, a path can be something like, if I create a canvas here, a path can be something like starting from here, here, here. Okay, so for example, the draw scope doesn't provide you a method to create a polygon, but if you wanted to do that, you can do so using the path, uh, uh, using the, oops, using the path method. Okay, so path is not just a magical things. It is just a list of all the lines that you be created while building that path. Okay, just to demonstrate it better, if I create a canvas again and you wanted to create I don't know what we call it, pentagon. Okay, so here will be one point from here. Okay, from here, from here, from here, from here. Okay, so to create a path, we define lots of lines with lots of coordinates. So we define the starting point here to here, then the second line will start from point B to C, C to D, D to E, and E to A. Okay. Once you provide a close connection, the uh, solid polygon is been formed for you. Okay. So this is also possible in uh, this uh, uh, canvas draw scope. Okay. So I hope, oh, Raj have already left the meet. Okay, I hope you all understand what I meant here by the graphics library, and we're gonna use the same in our application. Okay, so now we have a few points that we wanted to iterate. We're gonna go to our application. Okay, go to my main activity. If you see the code here, what I'm doing, I'm basically maintaining lots of states. Okay, and using those states I'm drawing my output. Okay, so I'm first mentioning the motion event. Okay, ideally giving it a idle motion event, that nothing is been happening. Okay, for as a default value, but I'm maintaining the motion event that I'm gonna trigger, and based on that I'm gonna draw things over my UI. Okay, I'm holding the current position and the previous position of the event, so that I can use that in order to create a connection between the continuous connection between the uh, path that I'm going to be draw. Okay, I've kept the paint object in order to give some property to the things that we're gonna draw. Okay, and whatever the properties the path will be taking in order to execute this stuff. Okay, now as you can see, as we have mentioned earlier, we have used the uh, pointer interrupt filter to get an event. Based on this event, I'm taking the x and y value. Okay, x and y value. Okay, and whenever the certain events happening, I'm defining the motion events with the specific mapping. If it is down, then down. If it is up, then up. Okay, why I'm doing so, I'm gonna let you know in a minute. Okay, also whenever this event is happening, I'm holding that offset value in a variable using the current position offset variable. Okay, this is coming from the documentation itself. I'm providing the stroke builder. Okay, and I'm keep on adding more points into it once the action begins and continue to happening. Okay, so in the down event, I'm adding the points. In the move events, I'm keep on adding the points. Okay, and once the things is been lifted up, I'm just adding the latest point is been where it's been lifted up, but not storing the current position in the action of thing. Okay, now you can see that in every actions I have added a print statement which prints the coordinates with the motion types that we need to uh, have a look upon. Okay, or basically that we wanted to track upon. Okay, if I do here, if I just search for motion here. Okay, let me delete it, or basically let me run it again. Comes to locate again. Okay, so now I've just going to tap on the screen. So once I've tapped on the screen, you can see motion event of motion down type has been triggered. If I move it here, okay, you can see motion event of type motion move is been triggered. And when I lift my finger from the uh, from my mouse, okay, you can see the motion up event is been triggered. Okay, in all of those ways we are collecting the x and y coordinates. Okay, and based on this x and y coordinates, we are providing those data to our machine learning model using the ink object. Okay, using this ink object. Okay, so I am doing certain things here, providing this providing this uh, ink object has been accumulated to my AI model. Okay, but still we haven't seen how the UI has been happening. Okay, so you can see on the pointers interrupt filter, I'm doing some calculation to accumulate the offset value. If I minimize this thing, you can see I have used the canvas object, canvas composable, which gives me a draw scope lambda, and inside it I am doing certain calculation. Okay, and once this has been done, I am calling this draw path method. Okay, and building the giving the current path and building the uh, UI for us. Okay, so whenever we do the down event, as you see, we have logged it here in the down event. Whenever the down event is happening, we update the current position variable. Okay, once this is happening, this when block is getting called, this down lambda is been getting called in the current path object, or the variable that I have created takes a path object. This is coming from the graphics library of Android. Okay, to generate the random path that we wanted to create. Okay, and in this path, I am telling him to go to this this current position, okay, setting the previous position to this one, okay, and whenever my cursor moves, okay, I'm telling my path to create a quadratic curve line, okay, taking the previous value and the new value and give me that output, okay. If I don't provide a quadratic behavior over this path, my output will always be have a crisp line like this, okay. Agar if I wanted to write n, let's say something like this with a little curve, I cannot do that. To get this curve output here and here, I have to use this quadratic equation to get this curve and get the smooth effect in our app, okay. So in order to do so, we need a previous position and the current position to get this output, okay. And similarly, in the down part, I'm just moving my cursor to certain position. In the move part, I'm drawing something, and in the up part, I'm saying that please connect whatever data you have to this current providing data, okay. Then I, because my cursor, my finger has been lifted up, I said that the current position is been not defined here, and the motion type is been set to idle again, okay. And whenever this current path value gets changed, because we have seen the reactive nature of compose, whenever this path is getting changed, this draw path is getting called, okay. And whatever I do here, okay, it's been able to drawn over the canvas, okay. So this draw path has been getting called multiple times in order to get this output, okay. Once we get this output, okay, in the click of this recognize button, let's see what I have implemented. So you can see, on the click of this recognize button, I'm calling a method from the view model, which is taking the ink object that we have created earlier, okay. So if I go to this recognize uh, ink method, you can see it is taking a ink object, and in the recognizer, I'm providing this ink object, and whenever I get a success, I'm setting up the recognized text value. And once it has been set up, okay, and I go recognize, okay, you can see I'm getting some output over here, okay. Though it's still very vague and very young to have a more promising output, but here we are learning how to work with the recognition ml kit and what are the basics of the uh, canvas and android graphics in general, okay. Now in order to get this recognizer object, I have to do certain more steps of things, okay. uh so before creating this recognizer object, I have to create a model object, okay. This model object is nothing but a recognition model of how you wanted this recognition to happen, okay. I've used the builder method and have built that, okay. Now this model object is coming from the model identifier, okay, where I am explicitly telling that whatever the input you get in your recognizer, detect it and give output based on your learning have been done on the English language, okay. Agar if I run this again, okay, if I do from the Hindi lipi and try to recognize it, you can see the model will not be able to recognize it based on the Hindi letters characters I provide. The reason being so, because I've trained my model to just give me output based on the US English level of the data. Okay. So once I have defined the option that from where I wanted to have a recognition, okay, I created a model. I give it to my recognizer, and everything works well. Okay, cool. But here it is. Here it is not just the end, because this text ink recognizer works offline. Okay, we need to download few data, okay, in order to make it work. This is completely offline, no server request, nothing has been happening at the background. Everything has been happening internally in your app. Okay, so you can see that whatever the client I'm been using, okay, that is this language model, that is the US level English. Whenever I use that, I have to first download this model. Okay, once the download has been happening, then only I can make the use of it. Okay, so let's see this in working as well. I have provided the download callbacks here. Okay, now let me copy this part. Okay, let me clear this app. Okay, or basically uninstall this app so that every cache value gets deleted. If I run this, go to the logcat. Oops. uh yeah, so you can see the download the model successfully, output is coming. So because I have explicitly downloaded this model whenever this view model is been initialized. Okay, uh, now let's say in order you wanted to support Hindi, Japanese, and other uh, language models, you have to explicitly download that model. Okay, and then only you can have a usage of it. But be very cautious that this model cost around 20 MB increase of your APK size per language. So be sure to have a uh, understanding of it, and if you don't need any model, you can just delete that model as well. Okay, so to maintain the app size of your APK. Okay, now with this being said, I'm gonna share this APK, sorry, share this zip file of this project. The next step of your of whoever watching this video is to take this project, clone it, or basically unzip it, and try to run it in your Android Studio. Okay, now try to implement this save to DB part and this clear board mechanism. Okay, okay, so try to do so. I have already provided you with the data layer and the DI layer. You don't have to do much of a task, but some few things has been pending in order to give you a learning exercise. Okay, so whoever watching, try to implement this save to DB task and this clear board task. Okay, and if you are able to successfully do that, and if you have a time width to do more, you can see this text path detector that we have implemented so far, it's not very good. Okay, so try to improve it as well, and for that you can take a inspiration from the uh, sample app that the Google have been provided for you. Okay, once you do so, you will have a very good learning experience, and you're gonna understand the depth of things in a much more context. Okay, thus you will be able to tell others that I have created this application from the scratch. Okay, cool. In tomorrow's session, we gonna implementing all those stuff. Okay, I'm gonna implementing all those stuff live, apart from building one more feature to accumulate all the learnings we have done so far. Okay, and as a bonus content, as tomorrow is our last class of this course, I'm gonna help you learn about Git and GitHub, and we're gonna upload all the things that we have built in our course to a public repo so that you can access it anytime, anywhere. Okay, with that being said, let's wrap up this session, and I'm gonna see you all tomorrow at the same time. Okay, so thank you.